Okay, so what we're doing here is we're using linear systems to solve this application problem. We have two situations in which we have two different types of solutions, and we want to create a third solution by mixing solution A and B. So you'll see we have a little graphic here that identifies our different solutions with the beakers. And what we want to do is we want to determine how much solution is needed to make a 500 milliliter solution that is 6% saline. And we need to create the mixture by having one solution that's 10% and another that's 4% saline. So how would we do that? And you can see here in the description it says, well, we're going to write two equations in x and y. And you could see by the graphic that the two different types of solutions are the x and y variables. Okay? So solution A is going to be x and solution B is going to be y. We're going to mix those together and create solution C. So how can I set up a linear system to find the appropriate mixture of each of the volumes of each specific chemical? So the first thing I'm going to do is I'm going to set up an equation, and I know that I need to create a 6% solution. So how much 10% solution do I need? So that's going to be x, but x is 10%. I'm going to add that to y, which is a 4% solution, and that is going to equal the 6% solution of the 500 milligrams. And so the way that I create this equation is I have 10% solution for x plus the 0.4%, or excuse me, the 4% solution of y is going to equal a 6% solution. Let me clean this up real quick. Is going to create the 6% solution of 500 milliliters. This takes care of our percentages. Okay, so we have a 6% of the 500, we have 4% of the y, and we have 10% of the x. But I need also the total volume, and the total volume is going to be our x and y variables. And so the second equation is going to be x plus y is equal to 500. So the first one represents our percentages, and the second one represents our volume. And so now we can get the percent mixture associated with the volume. Okay, so now we have our two equations. We have 0.10x plus 0.04y, be careful with the decimal placement, is equal to 0.06 times 500, and our second is x plus y is equal to 500. And quite frankly, the easiest way to solve this is going to be using substitution. So I'm going to go ahead and rewrite this. So this is y is equal to negative x plus 500. And I'm going to plug this guy in for my y value, not my x value. Okay? And here we go. So I have 0.10x plus 0.04 times negative x plus 500. And I'm going to simplify the 0.06 is equal to 500, and that gives me 30. I'm going to get the 0.10x minus 0.04x because of the distribution here. And then that is going to be plus 20 is equal to 30. I start to combine my terms. I get 0.06x is equal to 10, and I did that by subtracting the 20 and putting the x's together. And I get x is equal to 167. Now that I know what x is, I can go ahead and plug x, right? I know what this is. I find the easiest equation to work with. I plug in the 167, and I solve, and I get y is equal to 333. So in order for me to get the appropriate mixture, I need to take 167 milliliters of chemical X, or solution X, and mix it with 333 milliliters of chemical Y, or solution B is what we called it.